I can't make this full screen for whatever reason, so hopefully you can see that. Okay. All right, girls, face forward. We got to get through this. Okay, so f of x is our parent function, okay? So f of x is our starting point. Then each of these letters, A, B, C, and D, all do something different to the graph, okay? So I want to just take a look at a graph here to kind of, didn't work. It's good. All right, we'll just put this in the forefront. Okay, so if I have, let's just say f of x equals x squared. Okay, and if I were to take that graph, and for instance, let's just take f of x and change the a value. Someone shout out a value for a. 2? Oh, that was 3. What does that do? The blue one's what we're looking at. What's it do?
It moves it over like one square on each side.
Widens it?
Yeah.
So the blue one, so it makes it skinnier because the blue ones are inside one. But yep. Let's pick some other numbers. 5, same thing. 7, same thing. Okay, what about, yeah, can you get that for me? So let's try a fraction. Let's try 1/2. What does that do? Makes it wider. Each of these numbers makes it wider, okay? So that's what that value does. So what is actually happening, it's not like, it's not making it wider. What's happening is it's pulling it like Laffy Taffy. And so if you pull it, it's getting skinnier, right? So think of that A value as making the graph skinnier. So go ahead, write that down, that this makes, actually we're gonna call it a vertical stretch or compression. So stretch and compress is pushing down. Okay, it's a stretch if it's a whole number, and it's a compression if it's a fraction. Or I'm sorry, let me say that differently. It's a stretch if it's greater than 1, and it's a compression if it's between 0 and 1. So if it's a true fraction, not like a fraction that's greater than 1. Okay, let's kind of mess around with our b value. We're not going to do a ton with our b value, but if I make that b value negative, what happens to the graph? Oh, that did nothing. Okay, you'll just have to trust me on this one because it's not showing it on here. But what ends up happening is this is a, oh wait, no, it is. I'm just being silly. Okay, I'm going to shift this over a little bit so you can see. Let's try a different graph. How about that? Let's do x to the 3rd. Okay, so if you look, x to the 3rd is this one right here. And then negative x is this one right here. So what's happening to the graph? Over the y-axis. So that negative, well, it's actually flipping over this axis right here. It's like that. It pretty much does the same thing either way. But in this case, it's flipping over. No, you're right. I'm sorry. It's flipping over the y-axis so that x values are becoming negative. So this b value, we're only going to worry about it if it's negative. So if negative, it's going to reflect over the y-axis. So guys, you should be writing these down as we go. I'm sorry, I don't have it up on the thing. So A is a vertical stretch or compression, and then B, if negative, is a reflection of the x or the y-axis. And also something else that A does is if negative, it reflects over the x-axis. All right, let's look at that c value. So we've got f of x, and then if c, let's go back to x squared as well. So if my c value changes, someone give me a number. 5. So we're going to do minus 5. What happens to the graph? Which way? Right. And then if I'm adding 5, what happens? Goes to the left. So that c value is going to move it left and right depending on its value. So c is going to shift left if positive and shift right if negative. Writing these down, Haley? All right, finally, let's look at our d values. Our d values, someone give me a number. 60. Yeesh. I have to zoom out. Okay, what did that do to the graph? Moved it up 60. I'm going to go ahead and subtract 60. What does that do? Moves it down 60. So for D, it's going to shift up if what? If positive. And it's going to shift down if negative. All right, so those are all the transformations in a nutshell. So we're going to go about looking at the transformations a bunch of different ways. We've got graphs, we've got tables, we've got equations. Sometimes we're going to be asked to write the equations given the transformations. Okay, so here's one thing that I want you to know. If you are outside of those parentheses, so if you're changing A or D or both, what you're changing is your y values. So if you're outside the parentheses, you are doing a change in y values. If you are inside the parentheses, that's a change in x values. Okay, so A, if you have an A value, you're going to multiply it with your y values. If you have a D, you're going to add it to the y values because that's going to shift it up or down on the y-axis. And then similarly for X, if your B is, you're going to multiply by your B value or divide by your B values, and then your C values, you're going to add or subtract those. Okay? All right, so let's look at some examples that are similar to your homework. So it says for each function, identify the horizontal translation of the parent function. And then it gives the parent function right here. F of x equals x squared. So that's like we were doing over here. This is the parent function, the red one. And then we were changing it to be the blue one. Okay, so the parent function is our original function. This parent function in particular, x squared, is one that you should know. It's always going to be that U shape. All right. So if I have this function, this squared right here, this is a part of the parent function. So then what's the transformation that's occurring? What's the difference between x squared and what we have now? Look at these two equations. This one, oh, not that one. This one, and what's our difference? Emma? There's a +1, and Emma, is that +1 inside or outside the parentheses? Inside. So is that going to be an up-down or left-right shift? Left-right. Now we just have to decide if it's left or right. We got a 50-50 shot. If it's positive, it's going left. So we are going left 1. Now, what this wanted you to do is graph the function. So here's our original function, and we're just moving it to the left 1. I'm not going to spend a ton of time graphing it. I'm just going to give a rough sketch of it, just like you guys should have done for your homework last night. I think I said just do a rough sketch. The main thing is that you saw that it doesn't change anything else except it shifts over 1. Okay, so that's one example. It'll tell you to transform a graph that you already have. Sometimes it'll say change the equation. So for this one here, for 30, it says that you're given a graph for x, and the translation is up 5 units, and it's a reflection in the x-axis. So let's talk about what values are changing. If it's going up 5 units, what's changing? A, B, C, or D? D. Good. I think that was Connor. All right, if there's a reflection in the x-axis, is that changing A, B, C, or D? A. Okay, so what we're going to do is we're going to take this 4x and we're going to switch it, change it, rearrange it. So that 4x, if there's a reflection over the x-axis and our A is changing, A is then -1 or just negative. And then g of x, if it's up 5 units, are we adding or subtracting 5? If we're going up, we're adding. You're good. That's okay. I wrote +d, not +5. Okay, so that's all it wanted for that one. It just wanted you to take the equation you already had and then just change it around so we have those transformations. And I'm going to show you that on the graph just so we can be sure. So if I have 4x here, and I have -4x plus 5, you can see, sort of. So you see that this has been shifted up 5. It was started here, and now it's up here. But it's also been reflected because it has an opposite slope. Lines are a little bit harder to see, but for the most part, you can see that it has been reflected, and then its intersection point on the y-axis is up 5. Okay. So 33, I think, was actually a homework problem. Something I want to point out to you is that we have a 3x here and we have a 3x here. So that 3x in the g of x function is a part of the parent function. So I'm going to write g of x like this. Just, it's the same thing, just a different way of writing it. Let me actually erase these parentheses. Okay, so if I have 1/4 times 3x minus 2, this right here is just this cut into two things. What are the transformations? What's that 1/4 doing? What do you think, Emma? Yeah, it's a compression. So, and it's just asking for the transformation. So we're going to say there's a compression by 1/4. What's that -2 doing? It's outside the parentheses. Chase? Yeah, shifting it down 2. And that's all it wanted for that problem, was for you to just look at the equation from the parent function and the new transform function and just say, what happened to the graph, without ever seeing the graph. Okay, so those are ones where it says, what's the transformation? And then for some, it's going to say, okay, what's the equation? So for this, it says you're going 2/3 units down. So is that changing A, B, C, or D? D. This is changing your D value. So we have a function f of x. And then if we're going down, it's what? Plus or minus? Minus. So f of x minus 2/3. Just like that. That's all it wants for your equation. Similarly, this one here, it says you're reflecting over the y-axis. Now, is that going to change A, B, C, or D? Look live. What is it?
D.
So if it's reflecting or stretching or compressing, that's going to change A or B because it's a multiplier. Which one? B. This one's changing our B value. And what's happening to B? What is B equal to? If there's a reflection. Negative, yeah. So all that we're going to do is we're going to say f of x. This is where it kind of, well, actually, let's call this g of x since it's a new function. This is where it gets a little funny. We have to make our own parentheses. So if we have 3x, then my x is the thing that's becoming negative, not the whole thing. So if this is a change in b, but this would be a change in a if I had this. Do you see the difference there? In one, the 3 and the x are negative. In the other one, just the x is negative. So we don't want this one. We just want that one. All right. I think that's actually wait. We're gonna skip 18. All right, and then finally we have our table. Now tables are something we're gonna deal with a lot, and that's where it's gonna be important. If we're outside the parentheses, what's changing? X or Y? Y. If we're inside the parentheses, what's changing? Say it louder, Preston. X. X is changing. Okay? So if I am moving a unit down, is that a change in X or a change in Y? Change in Y. So are my X values changing at all? No. So I've got my X values are staying the same. And then my Y values, am I adding one or subtracting one from each of those values? What? Subtracting. So I'm subtracting one from each of these. So I get 0, -1, -5, 1. That's it. Okay? It is possible that it says a couple transformations. It might say 1 unit down and a vertical stretch. Or there might be both a change in X and Y if it says it's shifting up 2 and left 3. Okay, so just be aware of that. This is only one transformation. Okay, does that clear up what we were talking about yesterday a little bit more? Hold on to this. I think this stuff right here is going to be really helpful to you. I also, I would go ahead and copy down the stuff that's on the board over there. So that up, down, left, right, stretch, compress, reflect over X, and reflect over Y. I'm going to write it up here for take a second and write those down. Yeah.
You're not using this
For which one?
for this. Because this was like linear speed in terms of computers.
I guess I should have. I just used a conversion rate instead because it ends up being that your rate
And you do this.
your radius is 10.
Right, because I'll have to do that at the end here.
Yeah. And then your W, what is W again?
W would have been 4 revolutions per second.
Yeah.
So then we changed to 8 pi. Because this was originally W.
Yeah.
And then conversion to pi.
Yeah.
And then this would have been pi, sure. 10.
Yeah.
Okay.
All right. Any questions, comments, concerns? No? Okay. So let me close out of this. Stop.